Good afternoon, everyone, and welcome to today's session of your deep learning course. We are very sorry for today's session. We had some issues regarding our session today. That's why we started at 4. And today's session will continue till 5 o'clock, or depending on the length of the session required by the expert. So, Padmavati ma'am, I'm giving you the right so that we can start with the session.
Thank you, Sakshi. Thank you so much. I will start the session soon. Okay. Am I audible?
Yes, ma'am, audible and screen is visible.
Okay. Thank you. A small minor correction in yesterday's presentation. Yesterday's presentation was a fourth session. Okay. And one more slide that I wanted to highlight for yesterday's class was this. These were the different references I referred for yesterday's session, right? So coming back to today's session, today we will discuss in detail the process of training algorithm, and specifically we will discuss backpropagation, how backpropagation works with the help of small example. All right, let's start. This slide I have already covered in first and second session. Okay, that is training phase. But in order to go ahead with the backpropagation algorithm and to understand, let's repeat it, revise it once again. What is training phase? During training phase, we do not know exact values of the parameters. What we have in our hand is the set of samples, right? So what we will do is a set of samples. Again, we do have, as we are doing supervised learning. So I do have data points, xi, different xi's, and corresponding labels in terms of yi, correct? So with the help of given data, what we are trying to do is we are trying to predict the outcome. Fine. So during training, what we will do is we will develop a model, or we do train the model in such a way that our model should be able to give the correct result. Correct result again in the sense that whatever result output that my model is generating, okay, outcome that my model is generating, that outcome or predicted outcome, we say it as a predicted outcome, should be same as my ground truth outcome, whatever we have taken. That is, y hat should be equal to y, correct? So for that sake, initially, as I mentioned earlier, we do not know the exact values of the parameters. If we know in hand, if we are aware, these are the weight values required for training the model, then no need to go ahead with, or no need to compute the back propagation, or no need to compute the error. Directly, I will use these weights on my data set and I will compute the result. As we do not know the weight values in hand, so what are we trying to do in training phases? We are trying to learn the, or we are trying to at least reach to the actual values of W and B's. Okay, so for that sake, what we do is we do initialize the parameters with some random numbers. All W's, Wi and Bi's, okay, will be initialized with random variable values. And throughout the training process, what we will be doing is we will be learning the weight values, okay, desired weight values. In the next step, what are we trying to do is after initialization of Wi's and Bi's, we do compute the network output using forward propagation. We have already seen how do I compute the network output with the help of forward propagation with the help of in the last session itself, correct? So we with the help of pre-activation and activation layers of each neuron of each hidden layers, okay, we do perform some sort of computation in each layers, in each hidden layers and in each output layer, and at the end we will get the output, right? That is predicted output we will get. So the first step, very first step is in the training is after initialization, the next step is to compute the network output using the forward propagation. Okay, and definitely this network output, whatever it is generating, that is our predicted output, right? So what we will be doing is once we have computed the predicted output, we do compute the error. Okay, error between the ground truth and the predicted outcome. You do remember we initialized or we used the term y hat as predicted outcome and y as our the ground truth, the actual value. Okay, so in the second step of second step, that is 2b, what are we trying to do is we are trying to get the error. Okay, we will be computing the error by simply checking the ground truth with predicted outcome. This error will be very high in only in case when my predicted outcome is very far off from the ground truth, right? And in the next step, if it is far off, it is if it is far off, then what we will be doing is we will be checking the error rate. Is it equals to the equal to zero, or for some problem we may define some predefined threshold. With this much error, I'm my model is sufficient for the training. Okay, or I can say with this much error, if it comes, okay, for example 0.00001, then I'm okay with it. I can bear this much of loss, fine. So in those cases, what I will be doing is I will set the predefined threshold. Okay, so if my error rate is either 0 or predefined threshold, okay, if it is true, then what we will be doing is we will be completing the second step and we will be ending the training phase. Okay, suppose if error rate is greater than the desired result or desired rate, fine. So in that case, what we will do is we will update the parameters using backpropagation algorithm, and we repeat the entire steps of 2. Again 2a, 2b, 2c will be repeated. This process, second step will be repeated until and unless we do get this. That is, my error rate is less than 0, or if it reaches to the predefined threshold, then I will stop the training session, right? So how do this backpropagation works? It simply works with the help of 2 steps. I will be showing that those 2 steps in the next slide. Basically, how it update the parameter. Okay, it update the parameters with the help of this equation. Okay, every WIs should be updated. Every BIs should be updated. Okay, as I explained in the previous session, that whatever WI that we have initialized randomly, that may be far off from the actual whatever actual W's. Okay, so for that sake, if we take a specific set of there exists a specific pair of WI and BI, such that whenever I do consider those pairs WI and BI, okay, then my error rate will be equals to 0 or it will be equal to minimum. Okay, that is the threshold that we are considering. As we do not know those actual BI and WIs, so what we need to do is we need to learn with each particular step, with each iteration. So how we are doing, as I have initialized W randomly, I have initialized BIs randomly. So what I will be doing is from the initialized weights, I will be subtracting the weights. Okay, how much I will be updating. Okay, I will be updating. Suppose my loss is, as I explained, using that particular line W and W actual or with a specific W, I will be getting minimum loss. Okay, I may be getting very minimum loss only with respect to specific loss, but think that this particular point is indicating the WI, which gives me minimum loss. But what I'm doing is I have initialized randomly, I have initialized this particular point. So what I need to do is I need to move to this particular line. Okay, step by step I do move. So why I will be moving towards this, why not towards left side? Because I know that my loss decreases at this particular point. If I try to draw the parameters, the parameter versus the loss, then I know that my loss curve goes something like this. Correct? So I know with this particular law, with this particular parameter weights, my loss is minimum using this particular curve. Whereas whenever I have initialized W with this value randomly, I have initialized, so randomly I have picked this W. So I will check with respect to my y-axis, and my error rate over there is very high. Fine. So whenever error rate is very high, so what I need to do is I need to uh, like move towards the actual WIs. Fine. Similarly, when if I initialize WI, which is very high, so what I need to do is again, in this case, the WIs that I've initialized was very small than the desired WI. Okay, this is the desired WI, means this is what I want, right? Where my loss is 0. Fine. But I know with this particular WI, I may not be getting minimum loss, because minimum loss is over here, not over here. Correct. But in this particular case, my W, if you consider W increases with respect to x-axis, what happens whenever W is increases with respect to x-axis? I can easily say that with this particular W, I will get whatever loss I am getting, the least loss I am getting. But whenever I am initialized with this W, then my loss is in a similar way. Whenever I am increasing, whenever my WI has initialized with very high value, then also my loss is too high. So what I need to do is I need to come towards this particular desired W. Okay. So for that sake, I will be, this I explained with respect to WI versus loss. Similarly, there is specific desired or specific value of BI, which gives me minimum loss. For that sake only I said, for a specific WI comma BI, we will be getting minimum loss. Correct. So what we need to do is we need to check with what value or with what pair of WIBI I will be getting minimum loss. Fine. So that updation is required. That updation is done with respect to this. If the initialized parameters are low, then I will be increasing weight values, WI values. If initialized WIs are very high, then I will be decreasing those WIs, right? So the first step in computing in backpropagation algorithm is we will be computing the error. Okay, once we have computed the error, this error I have shown in case we are computing for one data point. Okay, this I've shown the error rate in case of multiple data points. If I'm feeding, if I'm trying to train my model with help of n number of data points. Usually we do go for this, right? So this for simpler examples, I have taken this equation. Otherwise, there is no, as such, there is no much difference between this equation and this equation. Here we have introduced only the m different data points. Okay, whereas here we are considering that m as only one single data point. Okay, first I will compute the error. Suppose error rate is high, as I explained in the training phase. If that error rate is higher than the desired result, then what I will be doing is I will be updating the weights W2, B2, W1 and B1. Because why I've taken only these four? Because in yesterday's class also we have seen two different neurons, right? One at the hidden layer, one at the output layer. So to train those two neurons, we do require four different parameters. Right? So for that sake, I have taken W2, B2, B1, W1 and B1. Only for the previous example, I wanted to illustrate this algorithm. I've taken this. Otherwise, in general, if you need to write down the second step, then you need to update the weights Wi and Bi by back propagating the error back into the network. This means with this particular, okay, I may be having this slide. Okay, so once we once we do forward propagation, we do compute uh, the predicted rate. After computing the predicted rate, I will check the error rate. If error rate is too high or greater than the desired result, then I need to back propagate this error. This error is need to be back propagated throughout this entire network. Okay, so that I will be updating this W2, B2, B1 and W1, because you can easily see that we only can change Wi and Bi's because X1, that is my input, is fixed. Even at the output, ground truth is fixed. How do I change Y hat? Y hat can, or the error can be reduced only by updating these values. So whatever error is, if error is high, then I need to back propagate in order to retrain the network with correct or with closed values of those WIs and BIs, correct? So let us consider this example. For this particular example, we will try to illustrate how do we back propagate in the network, or back propagate the error into the entire network. Again, the same example, only I might have changed some values over here. Okay, Wi and Bi and even input value I might have changed. Otherwise, this is representing input layer, this is representing hidden layer, only one hidden layer, and this is representing my output layer. This neuron of the hidden layer takes Wi and Bi, okay, weighted value of Wi of my input, and this particular neuron at the output takes weighted value of A1 and B2, okay, and it tries to compute the output. And here ground truth I have considered as 0.5, and the learning rate, that is 0.3. I've learning rate eta I have considered as 0.3. Okay, again we will discuss in detail if I reduce learning rate, what happens if I increase learning rate. Okay, maybe in the coming sessions we will discuss, and we will also try to demonstrate. Okay, so this is what I need to back propagate. That means I will try to back propagate my error to with respect to W2. Also, in the first step, I will try to back propagate error with respect to W2, and in the next step, I will try to back propagate the error W1 with respect to W as well. Okay, first let us see how do we back propagate this E, fine, to W2. So it can, with the help of this equation, so E, we have seen the this particular loss, okay, sum of squared loss many times we have seen. So the same loss I've considered 1/2 of t minus a2 square, okay. And do I compute a2? How I have computed a2? I have used some function, that is a2 is my activation function. Suppose activation function is logistic function. So in that case, a2 will be equals to 1 upon whatever we have done in pre-activation function, that is 1 upon 1 plus e to the power of minus z2, correct? That is what we have done. A2 is my activation function. I'm applying activation function on my pre-activation result, pre-activated result outcome, correct? So which is 1 upon e to the 1 upon 1 plus e to the power of minus z2, okay. And what about z2? Z2 can be computed with the help of W2, E1 and B2. Again, we have seen while seeing feed forward neural network, how do I compute pre-activation value? Pre-activation value comes like we can compute with the help of this equation, that is Z2, Z is equals to W into A1 plus here I will be considering this W2 and A1 and this B2. Fine. Fine. Let us see. How do I compute? See, how do I compute this? Before updating the value of W2, before getting this value, what I need to is I need to check what is the like derivative of E with respect to W2. Okay, what is the value of that is derivative of E with respect to W2. Once we know, we compute this, then we know this value has been assumed by us right now, and this value only need to be computed to get updated W2. Fine. So let us see how do we compute derivative of E with respect to W2. To get that, I will be checking, I will be seeing the error function, okay. Error function, I will, what I will be doing is will be computing dou e divided by what, dou a2. with with the help of different a with z2, and again once we do that result, I will be getting those two with respect to dou w2. So at the end, what are we trying to achieve? We are trying this particular result, that is dou e with respect to dou w2, derivative of E with respect to w2. This is a chain rule of derivation that you all might be aware of, right? You might have done in your math course. Okay, how do we compute, how do I apply chain rule over the derivative using derivatives? Okay, because I need to check derivative of E with respect to W2. So I will use this particular equation. And again, when I solve this particular equation, I need to solve this particular equation. Again, I need to solve this particular equation to compute derivative of E with respect to W2. So let us see this. Okay, now I will check E with respect to dou A2. So I got dou E with respect to dou E2, that is derivative of E with respect to derivative of A2 as minus TR of minus A2. I got, you all may be knowing, okay, when I apply derivative of E with respect to A2, what happens? This square, whenever I do apply derivative dx, okay, derivative of some function over x, and if that function is in terms of x square, then my derivative will be 2 into x. So in a similar case, I consider this as an x, and I do apply the same formula for computing derivative of a with respect to a2. So when we compute that, it comes out to be 2 upon 2 into t minus a2. Once we do that, what happens? Again, I need to solve with respect to this minus a2 because I am solving it for dou e upon dou a2. So when I apply further derivative, what it will return? It will return minus 1. Okay, so if there is some constant term over here, a2 into some constant term, I could have got t minus a2 into minus of that constant term, but I consider here there is no constant term. I have 1. So what I will do is I will be getting 2 upon 2. This 2 will come over here. Whenever we do apply x square, my derivative will be 2x, right? So 2 into this t minus e2 divided by 2 multiplied by minus 1. So for that sake, I have written dou e upon dou e2 as this. Okay. Similarly, dou e2 with respect to that f of z2. Okay. Whenever we do that, and my z2 is in terms of 1 upon 1 plus e to the power of minus z2. Okay. So whenever I apply derivative of a2, I will be computing with respect to z2. Whenever we do have this form of equation 1 upon something, then I will be getting this a2 into 1 minus of a2. So you can take this example as an homework and you try to first find out the derivative of a2 with respect to z2. You must be able to compute the output as a2 into 1 minus a2. Okay, if not, then we may take up in the next session, but you take this as a homework. Whenever I do compute derivative of a2 with respect to z2, so whenever I apply on this particular formula, you should always get, you will be getting a2 into 1 minus of a2. Okay, next, dou of z2 divided by derivative with respect to w2. How do I get that? So this time what I will be doing is I will be applying with respect to w2. Hence, what will be the result value? The resultant value will be, we know, if there is some constant term into x plus some other constant, and if I try to apply v2 over that particular function, then definitely suppose I do have ac plus b, and if I'm trying my function is a b, I have to compute derivative of c. Okay, derivative of this particular whole function ac plus b with respect to c. If I do that, I know I will be getting a1. Fine, because here there is no value of c, so this term will go, it comes out to be 0, whereas this term when I apply a derivative over here, I will get a1. Fine, so this is what I get whenever I apply derivative of z2 over with respect to w2. Fine, once we get, as I explained earlier, once I get this particular derivative value, derivative of e with respect to w1, whenever we get this, so I can easily compute w1 is equals to w1 minus eta of this, because I have computed this right now. I know this value, I also know this value. If all terms are clear, and that means if I know all terms, term values, then I will be able to get this, update this. So it can be computed with this particular formula now. I simply replaced derivative of E with respect to W2. I have replaced this with this. Fine. Because all terms are now, I am able to, I do have all term values. Okay, variable values. Hence, I can compute updated value of W2. In a similar way, dou E, okay, derivative of E with respect to derivative of B2. Right now, what we have done, derivative of E with respect to W2 we have done. Now we need to compute derivative of E with respect to B2. Same procedure, first derivative of E with respect to A2, derivative of A2 with respect to Z2, derivative of Z2 with respect to B2. Again, I will follow the same formula. Okay, that is chain rule I will be following. This is what I need. Derivative of E with respect to B2. Derivative of E I need with respect to B2. So for that sake, I need to solve sequence of functions. So this we have already computed. I will keep as it is. This also I have I asked you to compute. I have given the direct result. So it comes out to be this. Whereas derivative of Z2 with respect to B2 also I discussed. Whenever we compute any derivative, for example, WA plus B. So here I try to compute derivative of Z2 with respect to B2, then it comes out to be 1. Okay, and this derivative of this expression will be 0. You all know, right? It comes out to be 1. Fine. So once we get this equation, I will be updating that to update W2. Okay. Similarly, once we know this equation, I will be using this particular equation to update B2. Fine. Now, what we have done in the previous case, we have checked derivative of E with respect to W2, derivative of E. Now we need to compute derivative of E with respect to W1 and derivative of E with respect to B1. Correct? Now, it can be again computed. W1 equals to, this is just simple update rule that we follow. What I need to compute derivative of E with respect to W can be computed. Derivative of E, again apply chain rule till I reach W1. Derivative of E with respect to derivative of E2, E2 with respect to Z2, Z2 with respect to E1, E1 with respect to Z1, and Z1 with respect to W1, right? Now, what I will be doing is, we will try to solve each terms. Derivative with respect to A2 comes out to be this. Just now we have discussed while updating W2, that is while computing derivative of E with respect to derivative of W2. Okay, it comes out to be this value. Derivative of A2 with respect to Z2 comes out to be this value. Z2 with respect to E1 will come out to be this particular value. Derivative of E1 with respect to Z1 will come out to be this, and this comes out to be X1. You can go back and check the equation. Fine. And you must get the same derivatives. Now, let us try to get how do we update the B1 values. Again, B1 values need to be updated. A derivative of E, I will compute with respect to E2. Again, derivative of E2, I will compute with respect to Z2. Z2, I will compute with respect to A1. And derivative of E1, I will compute with respect to Z1. And derivative of Z1, I will compute with respect to W1. Okay. And when we solve all the derivatives, then
Excuse me, ma'am.
yes.
And there's some queries in the chat window regarding a voice break. Can we confirm that from everyone? Is you audible to everyone or not?
Yeah,
Am I
it is
audible
audible.
to you?
Audible. Audible,
Yeah,
ma'am.
now
Audible.
it is okay, ma'am.
Okay, ma'am. So sorry to interrupt you.
Thank you. Thank you, Sakshi. Fine. So once we compute chained with the help of chain rule, once we compute the derivatives, so I will be using this particular equation to update B1 as well. That is the first bias as well. Fine. Let us try to illustrate how do we backpropagate, or how do we try to update these W1, V1, W2 and V2 with the help of update rules, okay, of the backpropagation. For that sake, what we need to do is, as I illustrated in the initial steps, first we need to, these values, we need to initialize, or we need to compute the uh, output. Once we compute the output, then what we need to do is we can back propagate through the entire network. Okay, the name must be clear to you by this time. Forward propagation do compute in forward propagation in each neuron. Uh, in each neuron, I will be taking some value or some result of the previous layer, and I will be performing some computation. I will be forwarding the output of this neuron will be forwarded towards the right side of my network. That is, I'm feeding values from left to right. Definitely, I'm feeding. I'm doing some sort of computation, and again I'm feeding forward. Again I'm doing some sort of computation, again I'm feeding forward, right? In back propagation, I'm trying to check how do I reduce the error. Okay, and we know how do we reduce the error, because the desired result wi's or bi's may not be same as the desired one. They might have been initialized, that is w1 b1 w2 b2 we have initialized randomly. So we need to reduce, we need to move towards that desired wi's and vi's. Okay, so to move towards wi's and vi's, what we need to do is we need to compute, back propagate the error through the network from last once we compute the error, that error will be back propagated throughout the network till it reaches w2 and w1. Okay, let us illustrate first, it will be clear to you. Okay, by this time you all must be able to compute z1 given w1 x1 plus b and b1 values. Okay, and use that z1 value to compute a1. A1 will be computed with the help of logistic. You consider activation function as logistic regression and compute the a1. Once we know output of a1, w2 and v2, I can always compute z2 first, and once we compute z2, apply activation function, that is logistic function, then you do compute the output. Let's see. First you compute it and let me know the answer, because I've only updated it. In chat box you can paste. With the help of feed forward propagation, try to compute Z1 and try to compute A1, Z2 and A2. These we need it, right? I hope you are doing. Sakshi, is it fine to give the problem right now, or shall I mention the values?
Ma'am, you can give it now.
Okay, Sakshi. So better you take 5 minutes of time and do compute all values. Mhm. One person has done. Is it one? Okay. Yes, Z1 is it is correct. That is 0.525. Someone has computed Z1 for us. So you can consider 0.525 because it's correct. A1, no, this is not correct. Yes, Z2 is also correct, 0.3516. A1 is 0.6283, yes, very much correct. And we are only left with A2. So let me write down the values, compute the A2 as well. Let me write whatever values that you have obtained because it's correct, right? Fine. Set 1 is 0.525, A1 is 0.6283, and we need to compute A2, which is equals to 7 even yes, correct, 0.587 is A2. Fine. Z2, I could have written Z2 first, or anyhow, that's fine. Fine. These are the different values that we will obtain. Now, you can check the output that A2 is 0.587, whereas ground truth is 0.5. So suppose if I need the, okay, close this because all your answers are correct. Now let us continue. The ground truth value is 0.5, whereas the predicted value, that is A2, comes out to be 0.587. So in this particular case, we know there is an error. So because predicted value, the predicted value is not same as ground truth value. Okay, there exists an error. So what we need to do is, again, we need to compute derivative of E with respect to W2 and derivative of E with respect to W1, B2. Fine. So let us try to compute with the help of those equations. We only need to use these equations. Correct. We only need to use these values to compute or to update the weights. Weights is equal to W2 minus eta of this equation, that is derivative of E with respect to W2 comes out to be this. Okay, and W2 value, we know W2 value, it is, so place 0.13. Eta value also we assumed it as 0.3, so it is 0.3. Of the values we know, two value is 5, and rest of the values we ourselves have computed just now. So place those values. So now the updated value, it comes out to be 0.126025. Okay, so when you compare this value, weight value to previous weight value, you can easily say that your weights are reducing. Okay, that means your weights are updating. Fine. There is not a rule that always weight should be updated. Fine. So weight can be updated After updation, we may get higher value as compared to the previous weights, or we may get the reduced value. Here weights are coming out to be or reduced to less value. Okay, that is the previous weight value has been reduced with this particular weight value, W2. In a similar way, now come up with the B2. B can be updated with particular minus eta of this particular equation, that is a derivative of E with respect to B2. It comes out to be this, and you just place the values we have just computed, and you will get the value as this 0.26 something, and your earlier B2 was 0.27. Fine. Again, B2 we are able to update it. In a similar way, you can update W1 and B1. When you update W1 and V1, you simply use 1 equals to V1 minus eta of derivative of E with respect to W1. B1 equals to B1 minus eta of derivative of E with respect to B1. Okay. We know these values. Few of them we have computed. Few of them we like, or they are given the network W1 were given, right? So you can use and you can compute the updated value for W1. Now you compute the updated value for B1 as well. So once we compute the once we compute W1 and B1, there is some issue. Is the issue still there, Sakshi?
Yes, ma'am. At times there is voice break in between.
Okay. Is it fine now?
Yes, ma'am. It's better now.
Just minor breaking.
Okay. So wait, you we need to update W1. Similarly, we need to update the B1. Okay. Once we have updated in what we have done with the help of feed forward neural network or forward algorithm, feed forward algorithm, we get the predicted value, and we have seen predicted value is far off from the desired value. So we have, because there exists an error, hence that error is allocated towards the network. Okay. And again, we have updated our back propagated the error into the network in order to update the weights and biases. In the next iteration, in what you need to do is, again you need to compare forward propagation. This time, instead of compare forward propagation with the previous weight, will be, because I have updated it. So this time, with the help of updated weight, the forward propagation, again you will get the result.
Ma'am,
That is
still there is voice
predicted.
break.
I don't know. I have connected with Wi-Fi. There shouldn't be any issue like this.
Now it is clear. At times it is
Is it fine
breaking.
now?
I don't know, ma'am. When you are speaking at a very low pace, then your voice is very clear. When you suddenly take the pace, then it starts breaking.
Okay,
I
I don't
think
know.
some voice is there.
Okay, there is some network issue. I can't help it. Fine. So what we need to do is we need to update the weights. Based on the updated weights, again compute the forward propagation. With the help of forward propagation, compute the predicted value. Again compare the predicted value with the ground truth value. If the error is very high, again back propagate it. Again you follow this process. You will follow this process till you get the minimized error or zero error. Okay. And when we do the implementation part, no need to use the back propagation formulas. I mean to say, no need to use as such these formulas. because we do have frameworks as Keras, such as Keras. With the help of Keras, we can use because there is an inbuilt backpropagation which will happen automatically. So what we need to do is we only need to like use the forward feed forward propagation, that is forward propagation, and back propagation is done by automatically with the help of libraries, right? But anyhow, because we are learning deep learning course, so you all must know how do we reduce the error. Fine. So for that sake, I have taken this back propagation method. And this process will be repeated till we reduce, we either get the zero loss or desired loss rate. Fine. These are the few references that I have referred for this particular topic. Sakshi, I've done with today's session. If any doubts are there, then I can take.
Is there anyone having any doubt?
When are we going to move to Python practical?
Maybe
Like-
next week. Maybe next week. Coming week, I mean to say from Monday or Tuesday onwards. Parallelly, we will be doing. I will again check with Sakshi about the schedule. But according to me, we can go ahead with.
Is there any class tomorrow?
No, based on the schedule that I have received, there is no session that is planned tomorrow. Correct, Sakshi?
Yes, ma'am. We don't have lectures on weekends. Only weekdays from Monday to Friday.
Okay, ma'am. Thank you, ma'am.
I don't think there are more doubts, ma'am. We can end the session now then.
Yes, definitely. Thank you,
Thank you so
Sakshi.
much. Thank you, ma'am. So I have pasted the attendance link in the chat window. So everyone kindly fill that form on time, maybe within next half an hour or so. Otherwise, we'll close the form after that. Thank you.
Okay.